Going forward to what we have now, we have this generative adversarial network, the GANs, to generate what? In financial matters, they can generate time series and other types of financial data and help us to have better forecasting and better understanding of the financial markets and whatever is happening in the complex financial systems. So this generative time series and generative networks, they can provide us with these new technologies, some input that we wanted to ingest to our models, and by having a better input and better feature engineering and better data, the output for sure will be in the better accuracy. So what we can say about this GANs model, similar to what we had before, we have the real data that is representing what? Whatever is happening in the mechanisms of the real world. So there whatever is happening, the output that we can see is the data, and because it's coming from the real action, something that is really happening in the world, we call it the real data, and this real data is a representative of that real mechanism that is working in that area. If we have a market, there is something that is happening there, it is interesting for us, and we want to make a model to mimic somehow whatever is happening there, to know what really is happening inside of that mechanism or that system. So we want to make a model that model will give us enough information to, for example, forecast something for future, or maybe predict something that is important, right? So we have a mechanism in the real world. We can say process that is in the real world, and whatever the outcome is of that process is the data that we can observe. So this real data is here, and from this real data, what we can do, observe some of them that we can say a sample, okay? So we should do some calculations. A combination of the data, making some indexes that they can be ingested in our model and give us a better output. So we have to do something here, but let's say if we can make a kind of new data by this GANs or generative adversarial network. So if we have some random input here also coming from this approach, we have to generate a sample from all of these random inputs. So we need, similar to what we had here, a sample of it. And in between, we need a generator to make a random sample from these random inputs that we might have. So combining these two here, and then make a model by doing what? What might be the output of this? The discriminator loss, that is a loss for this discrimination unit. And as we have a generator here, we will have a generator loss also here. Okay? So this is originally proposed architecture for generative adversarial networks. So as you can see, this is the kind of revolution, right? To have these networks, and it will give us good opportunities for different financial fields and the problems that we might like to solve for the financial matters. So that was a basic model first for these GANs, but now that many applications are in the finance, that we can say the time series might be the first one. Okay, so for the time series matters, and the forecasting that we need for the time series of the financial data, the goal basically is prediction and forecasting of the market. So the different markets that we have in the financial system, usually we need the prediction for the different aspects of that market. And different models are using for this purpose. Different kinds of GANs, we can say all of these models can help us to have the prediction for the purpose of the time series forecast. So we can also use these models for portfolio management, the other application. What is the goal? We can use these models to fine-tuning of trading models, for example. So fine-tuning of training models, and we can use it also for what? Portfolio optimization. Okay. So, which kind of models they can be helpful for this part? Again, the different combinations of the technologies and modeling approaches with GAN. Mostly for fine-tuning of the trading models for portfolio management, CGAN and MAS-GAN. We can say also GAN-MP for the portfolio optimization. And the application in portfolio management. Okay. We can use also these models for time series generations. So, as we said before, the time series generation. That is what the synthetic time series generation and financial data augmentation. Okay, so making some data that is not coming from the real world, but they can help us to have the better models and better outputs. Okay, so finance data, augmentation or synthetic time series generation. So what can help here? We can say the time done. Also quant-GAN, the SD-GAN that we had before. They are the methods that they can be useful for this purpose. Okay. The other application of the deep learning and machine learning in finance is the fraud detection, right? So basically for the fraud detection, before we had kind of combination of the different methods. The signature recognition is one of them that is based on the data set that we have before from the different frauds. So if we have a new one, we can compare with the previous ones, and we can find out that if there is a kind of similarity, of course, with some differences, but totally they are similar to each other, and it could be a kind of alarm to know that something bad maybe is happening. But we have also some probabilistic models or the stochastic models that they help us to not only know about the frauds or about the anomaly activities that happened before, and we have some samples in the data set, but also know about something new that might happen without any historical data in our data set. We can somehow identify also this kind of frauds. So these are the anomaly detection methods, mostly based on some stochastic methods, that they could help us to figure out the distribution of that fraud or that mechanism of the anomaly behavior, and then use that distribution and that mechanism of the probability to predict that how much would be the probability that sequence of events be a kind of fraud, okay, or can have a kind of output that we can consider it as a fraud. So the fraud detection, like the other fields of the application for the deep learning in the financial systems, is something that benefits from machine learning a lot during the last years. So if said fraud detection, as a representative of all the frauds and the bad events that we might have in financial systems that might make the systemic risk for financial markets. We can say that it could be related to market manipulation, or as we know that the credit risk is the biggest risk that maybe the banks and intermediaries, the financial intermediaries, they face with. Something about predicting the credit card frauds, for example, or detection of credit card fraud could be also another good application. Okay, so credit card fraud, this could be another example. And a combination of the different models like LSTM that we said before. Nowadays, you can see many papers regarding to a combination or using preliminary this LSTM for the credit card fraud or the market manipulation. But now we have a combination of also new technologies and modeling approaches like GAN and LSTM that together they might have the better results. Okay. So these are the applications of the GANs and deep learning in finance, a summary for different purposes. For the time series forecasting, that we know that most of the models that we use to forecast for future, they know what might happen in the financial market is related to time series forecasting. So these kind of models are very important, and if we can have some new models that they can help us to have a better forecasting for future, they will be very, very helpful. And by using the computational power that nowadays are available, we can do it by using very complicated models. But when the inference is not the main goal, only understanding of the future and knowing about the forecast that we might have in future is important. These are the main options that we can think about. So for portfolio management, also for time series generation that we said, and the fraud detection that is for risk management, and also not only about fraud, but evaluation of the credit and market risk and operational risk. These are the main risks that we are thinking about them in the Basel III, Basel IV, the operational risk is very nowadays important, and there are complicated models that they are using to make a better predictions for also the operational risk nowadays in Basel IV or in Basel III, that we have mainly the market risk and the credit risk. So all of these models and the complication that we might put in our modeling approaches to have a better outputs and a better application are very important.